All right, welcome Year 11s. We are looking at 7A, hopefully get through 7A1, 7A2, bit of 7B in this video. Okay, and I'm just picking a few questions that I think might need a bit of explanation. And I've chosen this one, question 4, with Phyllis, the candle maker. Right, steadfastly refusing to embrace the modern electric light. Anywho, Phyllis has bought 770 metres of wick. Sounds like an awful lot of wick. For every candle, she only needs 27.5 centimetres. How many candles can she make? Now we've got metres here and centimetres. They need to be the same. I'm going to take the centimetres and say 1 wick equals 0.275 metres. All right, but she's got 770 metres all up, so she could do 770. Let me just undo that. 770 metres, and she could divide that up by 0.275 metres, and we could work out how many candles she could make. So I've got my trusty Texas Instruments calculator here. 770 divide 0.275, I think it was, equals 2,800. Good job, calculator. 2,800 wicks for candles. 2,000, here we go, 800 candles. Not 4 candles. 4 candles, that'd be handles for forks. This is 2,800 candles. Okay, so next, 7A2, question 9 is what I chose. Let's have a look. Where's that? 7A2. This is all perimeter. I think it's fairly straightforward. I thought question 9 was interesting, so I'm going to look at that one. We've got a bike wheel. So let's have a little crack at drawing a wheel. There we go, there's a bike wheel. Let's make it look cool, give it some spokes. There we go, bike wheel. It has a radius of 32 centimetres. When I ride to wheel, so let me read that again. When I ride to school, the wheels complete 639 revolutions. All right, so what's happening there is when the wheel, this is the ground here, right? This is the ground. And when the wheel's rolling around like that, it's going, say it's going that way. So by the time, this rolls around once, it's gone up to, I don't know, maybe there, right? So it's gone some distance from that point, rolled, around, and then it's come back again. I mean, actually, the bit that's touching the ground would go that way, wouldn't it? That way around. It gets back to there, and it's now the wheel's over here. So what we need to know is how far around is it around that circular wheel? Right. What we need to know is the circumference. Circumference, and that equals 2 times pi times the radius. Now the radius here is in centimetres. But they want to know how far this bike's going to go in metres. Right, so I'm going to do a conversion. We can do our circumference equals 2 times pi times 0.32 metres instead of 32 centimetres. And this wheel goes around, not once. Now what would that be? Pi is about 3. You've got about a metre there, but then you times by 2. This is about 2 metres, right? So it's going to be approximately 2 metres. But that's only one revolution. We've got 639. So we'd have to take our answer and times it by 639. Let's see if I can remember all that. 639, because I need a calculator. Let's have a look. So we've got 2 times pi times 0.32. And then we have to times that by 639. And we'll see how far we go. 1284.78. Now it said to the nearest metre was the answer. So the answer would be, see if it still writes in it. No, it's not going to write in this program. I'll go back. So 1284, but to the nearest metre, that's going to have to be rounded up because I've got a 0.7. So this needs to be rounded up. Remember, if it's 0.5 or higher, you round up. 1285. So the answer, the final answer, how far do I live from the school? The how far, well, it was 1285, that's right, approximately, because we rounded it, metres, okay? All right, let's move on to the next one. The next one, I thought I would do, what number? 12. Let's have a look at 12. I think it's over the page. Here we go. All right, we've got a conveyor belt, and the whole belt is 50 metres long. Seems reasonable. It's used to carry objects a distance of 23 metres. I like the way they've got a diagram here. It's going to make it a lot easier. What depth is the recess needed to contain this belt? All right, well, the diagram's going to help us here. Imagine we start here on the belt. Right, the belt is 50 metres long. It goes 23 metres. Then it's got this bit here around the circle. Then there's another 23 metres. And then there's that bit there. So you've got 23 plus 23 equals 46 metres. And that's on the straights, like on the top there and on the bottom. But we need to know about the circles. You got your left circle and you got your right circle, and the belt's coming around there, and the belt's coming around here on the right. And how many metres have we got left? Right, so we've got 4 metres of belt that belongs there and there. Okay, and we can combine this into one circle, you know, in some kind of weird arrow that I'm trying to do here. Look, it looks like a face now. There we go. So we could say that this is really like just one circle. If I put because I've got a half a circle here of belt, there's a half a circle there, and there's a half a circle there with the belt on the outside, and I put them together, and I've got one circle, and there's 4 metres of belt going around it, right? 4 metres. So I need to know the distance around that circle, or the formula, the circumference, it's 2 pi r. But I'm trying to find out x, right? X is the whole distance across the whole circle. It's actually a diameter, right? And there's another formula for circumference, looks like this, pi times diameter. Diameter. I think I'll use that, it's a bit simpler, right? 2 radiuses, there's a little radius. 2 radiuses makes a diameter, okay? But if I've got 2 radiuses, I don't need the 2 there. Yeah? I've just got pi times diameter, right? And we know what that equals. We know it equals 4. So we've got 4 equals pi times the diameter, which they've called x. Okay. So now I've got to find x. It's like x times by something equaled 4. You need to undo that. You need to divide. You need to divide this by pi to get rid of it. But if you want to maintain that equality, you'll have to divide this by pi. So x equals 4 divided by pi. Let's find out what that is. It's a bit more than 1. Maybe it's about 1.3 because pi is 3. Yeah, it's, so I'm thinking, well, pi is not 3. Pi is 3.14 approximately. Let's have a look. Stop trying to guess at it. Let's have a look. So 4 divide pi. It's 1.27. That's close enough. 2 decimal places. So we could say it's approximately, it's going to let me draw, no it's not. It's approximately equal to 1.27 meters. Okay? All right, now I'll stop the video there and we'll do another one for 7b.